Okay, so what the heck is a limit anyhow? The mathematical definition that I pulled directly off the internet. It's a point or value that a sequence function or sum of a series can be made to approach progressively until it is close to the point or value as desired. Whole bunch of mumbo jumbo, especially because we're not dealing with sequences or series in AB. We just care about those functions. So what I'm saying is a limit is a number that a function approaches when we get close to a given value of x. Okay, so what we're talking about. Ooh, that's a beautiful crooked line. Is we're going to pick an arbitrary x. We're going to pick a value right here. We're going to call it c. And we're going to pick values closer and closer and closer to x. And we want to know what's happening on the y-axis as we do that. And we're going to look at some examples where I am going to do my absolute best to make this a little bit clearer. So when I'm working with a graph and thinking about limits, I imagine that the graph is a road that I'm going to drive on. So here's our beautiful highway interchange. I don't know what city this is in. I just pulled a random picture off the internet. So let's imagine, let's just throw an x, y axis in here. And I'm going to pick just a random x. Let's say this one. We're going to call this C. And I want to know what's happening as we approach that value C. Well, it depends on what function we're looking at. So if you look on this road, if we're headed, we're going to pretend like, trying to see which way the cars are running. Yeah, they're going this way. So here, we're headed towards that point. But on the other side of the road, we're headed towards this one. So these roads are probably both named the same thing, right? Like this looks like northbound and southbound, vice versa, east-west. I don't know. I'm no good at directions, but we're going to call this north. We're going to call this northbound. We're going to call this southbound. So notice that my northbound people are headed towards a different value. Okay, they're headed towards a different point on my y-axis than my southbound. That's okay. Those are the one-sided limits that Delta Math is asking about and we haven't really dove into. Okay, so from the north, or from the left in this case, we're approaching this point in the trees. From the right, we're approaching right around this exit. Okay, and if we picked a different graph or road, I mean, maybe we're talking about this one. And in that case, the north and the south are headed towards the same place. Everybody's headed towards this little middle area. Okay, so a limit is just where the graph is headed. It's not where it goes. It's where it's going. Okay, it's a very important distinction. So luckily, actual functions don't have 4 lanes of traffic for us to try and muddle through. So let's look at this graph. Okay, so this is just a cubic, x cubed minus 3x, and I want the limit from the left and the right of -1. So first, let's practice notation. Notation is everything. If I want the limit from the left, then I'm saying the limit as x approaches -1 from the left of f of x. Okay, so here's -1. And what I'm saying is I'm going to start to the left of -1. Okay, so I'm going to start over here on the left of -1. I'm going to drive the road. This is my little car. It's not the hot rod I was driving in the last presentation. But here's my little car. He's driving along this road. Driving and driving and driving. And as he gets closer to -1, he's getting closer to 2. So we say that that's the limit. Okay, So he was northbound. So now what? Actually, he was coming from the left. Okay, so this is the left. Okay, well, what if I want to know about from the right? So let's say that my little sister, she drives this little dually bopper here. My sister is coming at -1 from the right. So she's driving, and she's driving. Hey, look at that. She's headed to 2 also. So in this case, we say that this limit is 2, because when I come from the left and my sister comes from the right, we get to the same place. Or we approach the same place. Remember, we don't have to get there, but we're approaching the same place. So we would say that the limit as x approaches -1, it really doesn't let me writing down here. Hold on. So we would say that the limit as x approaches -1 of f is 2. Okay, because from the left and from the right, we were going to the same place. We're like, yeah, we're going to meet in the middle, which is great. That means the limit exists. That doesn't always happen. So let's go on a different road trip. Here we go. So just like sometimes the northbound and the southbound parts of a road don't run parallel. So think about when you're in a big city, or even not a huge city. Let's just think about San Antonio. And you're like tooling along, right? And then here goes I-10 north. And then I-10 south doesn't always run right next to it. Sometimes they kind of veer off from each other, okay? So you approach different destinations, right? Like you can get to some source from I-10 north. That doesn't work. I-10 runs east and west. Why don't you see? I need somebody in class to correct me. I wondered why it sounded so weird. Okay, so somebody's on east I-10, somebody else is on west I-10. Okay, you can get to some shops that this guy can't get to, and vice versa. Okay, you're going to get to slightly different places. So that can happen in math. And what we say then is that the limit just doesn't exist. If you're not both approaching the same place, if you're going to miss one another, then it doesn't exist. So let's consider the limits from the left and right of 1 for this function. So we're going to start with the limit as x approaches 1 from the left. And let's say, by the way, there's an open circle here and a closed one here. Okay, who's going to be driving this time? My sister-in-law. We're going to put her on a nice flat road. So here she is. Okay, and she is driving towards 1. Her value never changes. The closer she gets to 1, nothing happens. She is at -3. So her limit is -3. No matter how close I take her to 1, that's all she's going to get to, -3. Well, what about from the right? Okay, so now we'll take my brother. Okay, he's going to drive along this little road. He works for the cable company, so he's got a bigger truck. And he's going to drive along the road, drive closer to 1. And as he gets to 1, I'm sorry. Why did I say 1? I meant 2.
CJ, will you call the front office, please? 2010.
All of this should be 2. I am so sorry, guys. You're probably thinking I've lost my mind. Okay. As we approach 2, the closer I get to 2, my sister-in-law stays at -3. That was true no matter where we went. But okay. As I approach 2 here, notice that my brother is getting closer and closer to 1. So his limit is 1. Now, I want you to stop and I want you to notice something. My sister-in-law never gets to the x value of 2. It never happens. That is an open circle. We're not talking about what it equals. We're talking about what it's approaching. And as she gets close to 2, she's at -3. And then he's at 1. -3 and 1 are not the same thing. Obviously. I know you know that. But just bear with me. These roads aren't going to the same destination. So this limit simply doesn't exist. Okay, because these roads are going to different places. My brother is approaching Ingleside. My sister-in-law is staying in Aransas Pass. They may get close. They're not going to the same place. So, guys, this is the beginning. We start with limits from graphs. And trust me, I know how hard it can be to wrap your mind around what's going on right now. So we look at graphs and we look at tables. But when we get to algebra, this actually gets easier. There are some tricks that you learn that make this better. We won't say easier, we'll say better. But keep asking questions, and I will keep trying to come up with clear examples and answers. Hopefully, this video is a good start. If not, you know how to get a hold of me.